Hello, my name is Ben Holsworth, and this is my Project 3 for Georgia Tech's Fall 2024 Design and Manufacturing course with Dr. Hassan Rashidi. Project 3 is about my personal interest in topics seen in class relating to manufacturing. So the first topic we're going over is sustainable manufacturing. Sustainable manufacturing essentially involves making the manufacturing process less wasteful and ensuring the safety of people and the environment. This often translates into using less energy, or at least cleaner energy, as well as reusing and recycling materials. By accomplishing these things, a manufacturer can cut down on costs while making sure their company doesn't impact other living things in adverse ways. Why sustainable manufacturing is so important. Sustainable manufacturing is important because reducing waste and energy use is the only way for the modern capitalist system to ensure it doesn't collapse under itself. Resources are inherently scarce, and so making the most of them is critical. In addition, the impacts of manufacturing on the environment are often extremely detrimental, destroying ecosystems and warming the planet. If this continues, humanity will no longer be able to survive on Earth. Capabilities and limitations. By designing for sustainability and practicing sustainable manufacturing, companies can decrease their costs and help to preserve both scarce resources and the environment. If many manufacturers do this, there will be much less waste and jobs will be created. However, there are, of course, some limitations to this approach. Namely, the changes will have to be implemented at the full scale of manufacturing across multiple companies in order to be truly impactful, which could result in large front end costs. The next topic is forging. Forging is a type of metals manufacturing that uses pre made templates to compress hot metal in order to shape it. There are numerous types of forging, including open die, closed die, impression, isothermal, precision, and incremental, with each type of forging serving a different purpose. In general, forging is used to create large, discrete metal parts, using two shaped die, which are the unforged parts, which clamp and compress over a hot metal piece to create a shaped piece. The aptitude of a metal for forging is called forgeability, and is based off of the material and its temperature. Why forging is important. Forging allows for the fast production of large and sometimes geometrically complex parts. It differs from other methods such as shearing and rolling in that it can create very large parts, especially in incremental forging. For example, IC engine blocks are often created with incremental forging. In addition, due to the material properties of metals in compression, parts created with forging are very strong, especially for their weight. This is due to the way that grains form in hot metals. Capabilities and limitations. Forging is extremely useful for creating large and complex parts quickly, as well as parts that need to be particularly strong. For example, I said earlier, engine heads are made with incremental forging because they're very large and need to be quite strong to withstand the forces within. In addition, there is practically no material waste, and the part has a smooth finish. However, there are some limitations to forging. The machines and tools have high initial costs and high upkeep costs, and forgeability must be considered. In addition, dies need to be very precise, or multiple dies need to be used. The next topic is milling. Milling is a machining process that uses a rotating piece to remove a small amount of material at a time. There are three main types of milling: slab, face, and end. Slab milling uses a mill that is perpendicular to the surface to remove material deeper, such as a slot. Face milling uses a mill parallel to the surface to remove more material but shallower, such as a shelf. End milling uses an angled mill to cut angled surfaces. The angle can be varied to create different surfaces. Milling is usually used on parts that have already been machined with other processes, but can sometimes be the only process used. The most common form of milling is end milling. Why milling is important. Milling is one of the most common and widely applicable machining processes, capable of producing limitless features and parts. It is used in almost all manufacturing, particularly for asymmetrical 3D parts and parts with small features. It can also be used to make surface contours and other smooth features. Capabilities and limitations. Milling's main advantage is its versatility, especially with CNC, which can also be used to fully automate the process. It can be used to complete virtually any operation, and with great precision and efficiency. Despite the excellent use cases for milling, it does have some limitations. Because the tool is moving very quickly, issues can arise such as chatter and high heat. Chatter is when the tool begins to rapidly wobble or stutter, which can cause major damage to the tool and workpiece. Chatter is usually caused by improperly mounted or tightened pieces, or by imperfections on the workpiece. Reconfigurable machines. A reconfigurable machine is a manufacturing machine whose structure can be altered to either change its rate of production or change what it is producing. Using reconfigurable machines allows manufacturers to easily change various aspects of the process, including part geometry, production volume and production rate, required processes, and material properties. This allows the pace of production to match demand, and also eliminates the need for multiple machines to produce similar products. Advances in computer control systems mean that these machines can be configured quickly and sometimes automatically. Why reconfigurable machines are important. Reconfigurable machines are the first step in the transition to more flexible and sustainable manufacturing. By using one machine for various products and processes, companies can cut down on cost of production, as well as energy use and waste, and pollution production. This flexibility enables faster adaptation to changes in demand or product design, reducing downtime and increasing efficiency. In addition, reconfigurable systems allow for easier integration of new technologies, keeping companies competitive. Capabilities and limitations. Reconfigurable machines offer the ability to adapt production quickly and efficiently, allowing manufacturers to produce different products on the same line with minimal human interaction. These machines also support modular upgrades, making it easier to incorporate new technologies and extend the system's lifecycle. However, there are limitations, including higher initial setup cost and complexity compared to traditional fixed systems. Additionally, while reconfigurable machines can switch between product types, there may be limitations in precision or speed compared to specialized machines that are designed for a single purpose and a single product. Our last topic is jet machining. Jet machining is a process that uses high-speed jets of material to cut through a workpiece in a small diameter. Water jet machining is the most commonly used jet machining process, as water is easily accessible and will not produce heat when it cuts the workpiece. The other type of jet machining is abrasive jet machining, which uses small particles such as silicon carbide or aluminum oxide, which are abrasive and quickly wear down the workpiece. These particles are usually shot out alongside a gas such as oxygen or nitrogen. These two types are sometimes combined when properties of both are needed. This is called abrasive water jet machining, and is usually used when more abrasion because of a tougher material is necessary, but cooling is also necessary. Why jet machining is important. Jet machining is a unique process that requires very little setup to use, and is very useful in finishing operations and working with brittle materials. Jet machining has recently emerged as a fast, cheap, and efficient alternative to shearing or milling processes, which require much more machinery and workpiece setup. The ability to tune the abrasiveness of the process is also very beneficial, as it can be used to cut anything from the softest to the hardest materials. Capabilities and limitations. Jet machining is able to quickly produce clean and precise cuts in almost any material. This makes it ideal for cutting thin but complex parts. Jet cutting also requires no particular start point and can be used effectively on soft, flexible, or brittle materials. which many other processes cannot. Water jet cutting produces no heat, which makes it extremely useful for cutting material that is temperature sensitive. Lastly, jet machining results in almost no burring and can even be used to remove burrs caused by other processes. Despite these many advantages, there are some limitations to jet machining. The machine parts will wear out very quickly, and the jet requires a lot of power, both of which will result in high operating costs. In addition, jet machining cannot be used on thick workpieces due to jet divergence. These are the resources used, including the class slides. Thank you very much for listening.